right, good morning. Happy Easter morning. This is your lesson for Monday. You will need your own sheet of paper, and I think you're going to be pausing a lot to copy the notes. So I am sending you a blank sheet of paper for part of your notes, but this you're going to have to do on your own. So hope you're enjoying your long 3-day weekend. I will be sending you this probably tonight. Anyway, let's get started. Yes, I already made a mistake, but you know I'm a tree hugger, so I'm not going to start over. This is supposed to be angles and their measures. So we're continuing on in our trig unit circle, and I'm going to start right here explaining some of this vocabulary here. Right here we're going to start with angles. Of course I have your X and Y axis. And I want to tell you, when you're building an angle, you always start here on the positive x-axis. So if I'm going to start building an angle, my first angle I'm going to draw is, I'm going to keep it in quadrant 1. So I'm just going to draw an angle. I don't need to know what the degree is. So I'm going to draw this angle right here. Looks like maybe a 55 or 60 degree angle. That really doesn't matter. I'm going to draw my symbol for theta, since I don't know what that angle equals. But you always start an angle from, this is important, from the x-axis. This is where everything begins. So right here, I'm going to highlight this in yellow. This is called your initial side. Where you begin an angle is your initial side. That's your initial side. That's where you begin an angle. So that's my first vocabulary word I want you to know. Now, where an angle ends is called its terminal side. So when I have this is where my angle ends. This is called the terminal side. So there's your two first vocabulary words. You always want to start on the positive x-axis, and then when you start, if I'm going in this direction, this is a positive angle right here. So a positive angle moves counterclockwise, and this is where most of your angles do. We usually go counterclockwise and make them positive angles. So positive angles move counterclockwise. Counterclockwise. So I start on the x-axis, I go counterclockwise to move my positive angle. Now I can make a negative angle. You still start on the x-axis, you just go clockwise. So let's say I'm going to build a negative 120 degree angle. So I'm going to approximate, I don't know where 120 degree angle is, but I know that from here to here this is 90. So I'm just going to go in this direction. This is clockwise. I'm going to say it's about right here. So I went clockwise. This is my initial size. This would be my terminal side where my angle ends. So this is a negative angle because I went clockwise. So to make a negative angle, you go clockwise. Seems backwards, doesn't it? Okay, so there's your first thing about how you build an angle right there. And you probably learned that in geometry, just brushing up your memory. Okay, so I think you can still see pretty good. I'm going to talk now a little bit more about angles and their ordered pairs. So again, let me just put a few degrees on here. So if I start right here on the initial side, of course, hopefully you know this would be 0 degrees. And as I move in 90 degree increments, this would be 90 degrees. Add another 90, this would be 180. Add another 90, this would be 270. And then if I make a full circle, I'm back at 0 degrees or 360 degrees. So that's going all the way around here. So then I would know, let's build our quadrants. I think most of you know that quadrants go backwards. That's why we have an angle goes counterclockwise. That's why our quadrants go counterclockwise. So this would be quadrant 1. This would be quadrant 2. This would be quadrant 3. And this would be quadrant 4. This is going to be important when we start building or doing SOHCAHTOA and adding our trig. We're going to have trig order pairs and stuff. And that's why built this over here. So again, you're gonna maybe wanna pause and write this down. So this is just gonna tell us our quadrants here. So anything from 0 to 90, in between, notice they don't equal, anything between 0 and 90 degrees is in quadrant 1. Notice there's no underline here because there's something special about if it's on the x-axis or if it's on the y-axis. So anything between 0 and 90 degrees is in quadrant 1. Anything between 90 and 180 is in quadrant 2. Anything between 180 and 270 is in quadrant 3. And then anything between 270 and 360 is in quadrant 4. Again, you can pause that later or pause it now, whatever you want to do. Okay, so what happens if I build an angle and let me actually, well, I don't want to build one because there's other stuff I want to write on here. So if I have an angle, I can actually do it up here and it touches right here. So it touches on the 90 degree. Well, that's called a quadrantal because it's not in quadrant 1 and it's not in quadrant 2. It's right on the y-axis. So those are special angles. They're called quadrantals because they're not in a quadrant. So quadrantals are these angles. If it's 0 degrees, if it lands on 0 degrees, or if it lands on 90, if it lands on 180, if your angle lands on 270, or one more, and that would be 360. Whoops. So any angle that lands on the x or y axis is not in a quadrant, it's in a quadrantal. Okay, so that's what this is for. Okay, now one other thing I want to do is I want to do a point because I want to teach you about some other parts. This is just kind of introduction right now. So if I gave you this point, let's see, let me give you point 1, 2, 3, 4, 5, 1. And if you were to write that point 5, 1, most of you would recognize that your 5 would be your x and your 1 would be your y. Well, in trig, your 5 would be like cosine and your x would be your cosine and your y is your sine. So this is something you need to know for trig. And the beauty about this that I like, it always helped me remember, is cosine it goes alphabetical, just like x and y. So cosine is first, sine is second. That almost looks like a 5. Now, in quadrant 1, everything is always positive. So your cosine is always positive, your sine is always positive. Because anything that lands in quadrant 1 is always positive. So if I go over here, and I have cosine is first and sine is positive, well, if I go left, my x's or my cosines are negative, my sines go up, so my sines would always be positive. And you're going to learn this later, but this is kind of nice to have this to refer back to in your notes. So you may want to keep this, if hopefully you're still keeping notes. Then if I go down here to quadrant 3, if I go x and y, or cosine and sine, I go left, that's negative, I go down, that's negative, so my cosines would always be negative in quadrant 3, and my sines would always be negative. I might as well put little parentheses around this so you think of it as an ordered pair. And you'll see this when we build the unit circle. And then over here in quadrant 4, if I go right for my cosine and down for my sine, my cosine in quadrant 4 would always be positive. Down, my sine would always be negative. And this is going to be something of value for sure pretty soon. Okay, let me put parentheses around here. Just some information. Okay. All right. So one thing I still want to build on this is coterminal angles. Coterminal. Well, if I have a lot of co-teachers I work with, they're partners. We do the same thing. They're my co-workers. So a coterminal angle does this. They have the same terminal side. So I'm going to draw a picture of a couple of coterminal angles. How am I doing on time? Pretty good. All right, so let's say I have an angle. Let me grab a different color. And I'm going to draw a positive angle first. So I'm going to draw a positive angle here in quadrant 1. So I start at the initial side, and there's my positive angle right here. And here's the terminal side. Well, I want to draw another angle that's coterminal to that. That means it's going to end there. So I'm going to draw a negative angle that's going to end there. So if I draw a negative angle, I'm going to start here, and to make it coterminal, it ends right there. So if that was a 60-degree angle, this would be a negative 300-degree angle, and they would share the same terminal side. That's called coterminal angles. And let me move this up a little bit so you can see this. So coterminal angles share the same terminal side. Share the same terminal side. Okay. Share the same terminal side. And look, you can even make a coterminal angle that looks like a snail. Watch this one. So I'm going to do another one. I'm going to do a third angle. I'm going to make it positive. So I can go like this. I can go here and I can do a 360, keep going, a 720, plus 60 more, and end on that same side. There's another one. So 720 plus, what did I say that was, 60? So that'd be a 780-degree angle right there. It still lands on the same terminal side. Okay, it's pretty cool. Okay, right down here, we're working with degrees, and that's all we're really going to do today is just degrees. But I want to show you, we're going to be working with radians, and I want to show you what happens with a radian. Radian is, if you see the word radius here, this is my radius right here. This is kind of cool, where you get like the formula for circumference is pi times diameter, pi. Here's where pi comes from. So this is radius right here. If I wanted to go around the circumference here, and I take that piece off, that's my radius, and I go, okay, well there's 1, and, oh, great. It's easier when it's flat. It's easier when it's flat. 1, and hold it there, 2, put it there. I got 3 plus a little bit more. How about, I bet it's 3.14 more. So if that's 3.14 more, gee, what's 3.14 equal? Huh, that's pi. 3.14 is pi. And then if I go around another 3.14, there's 3 and a little bit more. All the way around the circle then is 2 pi. These are called radians. You're going to learn radians on the unit circle too. And that's where radians come from the radius. So halfway around the circle is pi. All the way around the circle is 2 pi. So guess what 90 degrees is? Well, if that's pi, this would be half pi. If that's pi and that's 2 pi, that would be 3/2 pi. But that's going to come another day. So I'm going to turn this off and get ready for part 2 today.